Alright, and in this video we're going to look at a couple of different topics. We're going to look at graphing a couple of points on the XY plane. We'll talk a little bit about different types of symmetry that we can have on the XY plane. We'll do an example of using the distance and midpoint formula. We'll get into some linear equations, and then we'll finish up with some literal equations. So we'll go ahead and draw in a Cartesian coordinate system, or the XY plane. Has two lines. The horizontal axis is your x-axis, and the vertical axis is the y-axis. And you can change your scales for your x and y-axis. I'm going to go ahead and go by 5s. Okay. All right, and so we're going to be graphing some xy pairs. Okay. Oops, let's not do yellow because yellow is hard to see. So we have an xy pair. And the x is going to control left or right, so you'll start at the origin, and you'll either go left if the x is negative. If the x is positive, you'll go to the right. Afterwards, your y, if it's positive, you'll go up from there. If it's negative, you would go down from there, however many times for plotting some points. So this should be a review here. So we're going to plot a number of points, and then we'll go ahead and talk about some symmetry there. So let's see what we want to plot here. So we're going to plot the following points. Okay, so point A is going to be the point 1, 0. So we're going to go to the right 1 and not go up or down. And that's where point A is going to be. There it is. We'll go ahead and label that. Point B is going to be 0 and negative 3. So we're going to start at the origin, and the x is 0, so we don't go left or right. We're just going to go down 3 times, so we're going to be down there. Put that point in and label it B. Point C is negative 1 and 2. So we're going to go left 1 for the x and then up 2. We'll label that point C. Point D will be 1 and 2. So we're going to go right 1 and up 2. They're both positive. We'll label that point. Point E is going to be 1 and negative 2. So we're going to go to the right 1 and then down 2. And finally, point F is going to be minus 1 and minus 2. So we're going to go left 1 and then down 2. Okay, so there's point F, and then we're going to talk about some reflections here. What do the ordered pairs look like? So if I have an xy and then we reflect to minus x, y, what that's going to do is that's going to reflect over the y-axis, and we call that. Sometimes if we're talking about a function later on, we'll call that even. That's kind of like if you take your piece of paper and you do a hot dog fold from elementary school. That's what we got for a hot dog fold or a y-axis symmetry here, or y-axis reflection here. So the points that are reflections of each other over the y-axis are C and D and F and E. Okay, so F and E and also C and D are reflections of each other. I guess technically B is also a reflection of itself on the y-axis because it's on the y-axis, so I guess we could say that also. But that's typically not what we would talk about when we're doing symmetry. All right, if we do an xy to a minus x and minus y, that's going to reflect over the origin. And the best way to do that is to, flip your piece of paper over, and if it lines up on itself, then that is going to be origin symmetry. So D and F are going to be symmetric with the origin. So if you're looking at the computer screen or your phone or something like that, and you turn it upside down or turn your head upside down, then they're going to line up in the same location. Similarly, C and E are also going to be symmetric with respect to the origin. We also call it odd if we're talking about a function. We'll get into that a little bit later. The last type of reflection we'll talk about is reflection or symmetry is over the x-axis, and we'll mention it. It'll appear a little bit, but predominantly we'll be doing y-axis and origin type of symmetry. So if we have an xy and then that gets reflected to x and negative y, that's going to be a reflection over the x-axis. And we don't have a name for it like even and odd, because those entail some sort of function, and so x-axis reflections and symmetries will not be a function. We'll talk about that later on. Okay, so D and E and C and F are going to be reflections over the x-axis there, okay? And then I went ahead and labeled this as problem 1 to match the notes there, okay? All right, so that's just a little overview of graphing on the XY plane. We'll certainly be doing more graphing later on, but right now we're basically going to talk about how to plot some points and then maybe do some reflections of individual points. So the next thing we're going to take a look at is the distance and the midpoint formula. We're going to be mostly interested in applying it, so it'll give us a little bit of practice with for at least the distance formula for simplifying radicals. The distance formula can be derived from the Pythagorean theorem. We'll talk about Pythagorean theorem a little bit later when we're doing some applications with geometry. So the distance between a point x1, y1 and a point x2, y2 is going to be given by the distance d is equal to the difference between the x coordinate squared plus the difference between the y coordinate squared, and then all of that under the square root. So to apply that, we're going to find the distance between, let's see what points they're giving us. So we're going to find the distance between 4 and negative 4 and negative 3 and negative 2. And the one thing we have to be a little bit careful of is the negative signs that come with the formula. So you see you have a minus here and here. Those come with the formula, so we got to be a little bit careful if the numbers are negative. I've also gone ahead and labeled x1, y1, x2, and y2 to kind of help myself out, plug everything into the formula. We'll do that again when we're finding slopes of lines a little bit later. Okay, so let's go ahead and drop that into the formula. So distance is equal to 4 minus negative 3. So you got to be a little bit careful there because this minus sign comes with the formula. Okay, so 4 minus negative 3 quantity squared plus negative 4 minus negative 2 quantity squared also. And remember, order of operations, we're going to have to do these parentheses first. And so when we're subtracting a negative, that's a good thing. So 4 plus 3 will be 7. And then negative 4 plus 2 will be negative 2. So we have 7 squared plus a negative 2 squared, and that's going to give us 49 plus 4 under the square root, and that's going to give us 53 under the square root. Now on the homework system, I think they're going to want you to give the exact answer. If we were doing some sort of application in the real world, we'd probably want to go ahead and stick square root of 53 into the calculator. Anyways, but for the purposes of putting it into the on the computer, probably leave it as square root of 53. If it was something we could simplify, like we did in the previous, I think it was the previous video, then you could, if I had like the square root of 8 or whatever, that's 4 times 2 under the square root, so 2 root 2. So that's what I'm talking about. We did that in the previous video. Okay, so that's the distance formula. We're going to go ahead and take a look at the midpoint formula. And the midpoint formula is essentially we're going to take the average of the x coordinates and the average of the y coordinates. Okay, so midpoint. So the midpoint of the between 2 points, or the line segment, however you want to describe it. The points being x1, y1, and x2, y2. We can go ahead and call it the letter M. Later on, M will be for slope, but here for midpoint, so average of the x coordinates, average of the y coordinates. Now this is easier than the distance formula because there's no subtraction in the formula, and also we're not dealing with the square root. So for our example here, we're going to find the midpoint between the points 3, 4, and 1 minus 3. So find the midpoint of the line segment from 3, 4 to 1 and minus 3. And then I'll go ahead and keep with the convention. We'll go ahead and label our x1, y1, x2, and y2. Okay, so our midpoint is going to be the average of the x coordinates, so 3 plus 1 over 2, and the y coordinates 4 minus 3 over 2, and that's going to simplify down to 2 and 1/2. So if we actually went through and plotted those points, the midpoint would be at 2 and 1/2. Okay, so that concludes the kind of the stuff we're doing with ordered pairs. Now we're going to transition into which should be still review solving some linear equations. We'll do some equations with fractions and some stuff that might not look like it's a linear equation at first, but ends up being a linear equation. And finally, we'll do some literal equations. Okay. So for solving linear equations, the goal is to isolate the variable. Okay. If we're doing quadratics or other types of equations, we'll have a different strategy. So I sum it up with do upon one side of the equation that you do upon the other side of the equation. So do upon one side of the equation that you do upon the other side of the equation, and the goal is to isolate the variable. Okay, so we're basically we have the golden rule for equations here. Okay, so do upon one side of the equation that you do upon the other side of the equation to isolate the variable. Okay. And let's go ahead and solve some. So we're going to do negative 2 minus 2 times the quantity x plus 4. That's going to be equal to 2x plus 1. All right. So I'm going to follow the order of operations. So I'll do parentheses, exponents, multiplication, division, all that kind of stuff. And so what I got going on here is before I do anything else, I'm going to go ahead and do the distributive property there. So I'm going to distribute that minus 2 through. Then we'll get into collecting like terms. So we'll distribute the minus 2 through. Okay. We do have like terms. So that's going to be minus 10 minus 2x equals 2x plus 1. You got variables on both sides of the equation. It does not matter. You're going to get the same answer, but you need to pick the side to move the x's to. So it looks like I'm going to elect to move the x's to the right-hand side. So we're going to add 2x to both sides. And we can be efficient. We are moving x's to the right-hand side, so that means we're going to get rid of the 1 there. So to get rid of that plus 1, we'll subtract 1. And if you want to, you can do like the crossing out thing. You don't have to, but that's fine if you want to. Okay, so we got minus 11 is equal to 4x, and to undo that multiplication, we're going to go ahead and divide both sides by 4. We get negative 11 over 4, and that is going to be equal to x. Now you certainly can plug that back in and check. I think the homework system will probably take decimals. I see what they ask for. I'm fine with you leaving it as a fraction. Probably not converted into a mixed number. So what that would look like as a mixed number is negative 2 and 3 over 4. So I would stay away from converting it into a mixed number. But if you wanted to write it as a decimal, that would be fine. Provided that the homework online says decimals are okay. If it asks for a fraction, leave it as a fraction. All right, let's go ahead and try another one of a very similar type. So this time we're going to have 12 times the quantity x minus 7 equals 28x minus 256. Now when we're getting into the equation solving, might be a good idea if you're feeling pretty confident with it, go ahead and try solving it on your own. If you get the same answer, that's great. You're good to go with that type of problem. If you solved it a little bit differently than I did, that's fine too. There's more than one way of solving these. So if you took a different route, if you did things a little bit more, you did this part right here in 2 steps, that would be fine also. So you can always pause the video and try to work out the problem first. If you get stuck, then you can start watching the video and see how we work it out on the video. All right, so for number 5 here, we're going to go ahead and do that distributive property. So we're going to have 12x minus 84 equals 28x minus 256. And here we have to decide which side to move the x's on. Again, it does not matter. You're going to get the same answer either way. What I'm going to do is I'm going to subtract 12x from both sides. That's going to move the x's over to the right-hand side, which means we need to move the 256 over, so we're going to add 256 to both sides. Okay, so we're going to subtract 12x from both sides, and we're being efficient. We're going to also add 256 to both sides. If you want to do this as two separate steps, that's perfectly fine. If you want to write out the crossing out there on each side, you can do that also. So we're going to have 172 is equal to 16x. We'll divide both sides by 16, and we can reduce by 4. So you can divide the top and the bottom by 4. That's about the best we could do. So we do want to reduce our fractions. So we divided the top and the bottom by 4 to reduce our fraction, and we're left with x. Okay. All right. We're going to look at a couple of problems where we have some fractions, and so how do we handle it if we have fractions? So let's see what we got going on the next problem here. Okay. So here I have 8 over x plus 2 over x, and that's going to be equal to 12. There's only one denominator, and that's x. So what we want to do is clear the fraction, so we're going to multiply everything by the least common denominator. There's only one. It's x. They both have an x, and the LCD is x. The thing with fractions, if I do have a denominator that has a variable, so we have the variable x, thou shalt not divide by 0, so we may have a restriction. So the denominator is x, x can't be 0. Okay. Now, the nice thing about this one is we have a common denominator. They both have a denominator of x, so we can go ahead and add that and have 10 over x is equal to 12. Now we're going to multiply both sides by the common denominator, which is x, okay? Or you can do x over 1. X is the same thing as x over 1. Why I might want to choose to use x over 1 is when I'm using a fraction. It helps things line up a little bit better. Okay, so we multiply both sides by x, do upon one side of the equation that you do upon the other. Okay, on the right-hand side we have 12x. On the left-hand side we have what's called cross-canceling, cross-over multiplication, so the x is absorbed. We're left with 10. And then to solve it, we're going to divide both sides by 12, because that's how the 12 and the x are connected with multiplication. Opposite is to divide. And then we'll reduce and we get 5, 6. Which is not our restriction of 0, so we're good to go. Not a problem. Okay, we're going to go ahead and look at another example with a fraction. So we're going to have x minus 2 over 5 plus 5 equals x minus 1 over 4. There are two denominators. They are 5 and 4. We're going to find the common denominator, which is 20. I don't have any variables in the denominator, so I'm not going to have any restrictions. So there are no restrictions on this one. We're going to multiply everything by 20 or 20 over 1, depending on if it's a fraction or not. Okay, so I'm just going to rewrite the problem with a little bit of space. And then I'm going to multiply everything by 20 or 20 over 1. So 20 over 1, decorate with parentheses because we're multiplying. 20 over 1, decorate with parentheses because we are multiplying. Okay? 5 goes into 20 4 times. So we have x minus 2 quantity times 4. Plus 5 times 20 is 100. Equals 4 goes into 25 times. X minus 1 times 5. Once you get the fractions cleared, it's usually not too bad of a problem. So now what we need to do is we need to do the distributive property on both the left and the right hand sides, collect your like terms, and then to figure out which side you want to get the x's onto. So distribute the 4 through, and distribute the 5 through. Collect your like terms, so negative 8 and 100 will make 92. Okay. Now, I'm going to decide to move the x's onto the right-hand side, so I'm going to subtract 4x, and I'm going to add 5. Subtract 4x, and add 5. So 97 is equal to x, and that's it. You can go ahead and plug it back into the original equation to check to see if it works if you like to. Okay. Now the next problem is going to be problem number 9. I think something happened with my ordering scheme. I forgot a number there, so we left out poor 8 there. We're going to go ahead and look at problem number 9 here, which does not have fractions, but it's going to be a little bit different here. And what it looks like to me right now is a quadratic. Okay, so quadratics will come a little bit later. It's not really a quadratic. It ends up being a linear equation. It just looks like a quadratic for the time being. So one thing to remember, that x plus 3 quantity squared means x plus 3 times x plus 3, and so we'll have to FOIL that. Okay, we'll FOIL the left-hand side, which will be x squared plus 2x minus 8. FOIL the right-hand side, x squared plus 6x plus 9. Now, you see you have an x squared on both sides, so if I subtract x squared from both sides, those are going to cancel out, so it is, in fact, a linear equation. Okay, so it is no longer quadratic. The x squared is the quadratic term. That's gone. So get 2x minus 8 equals 6x plus 9. We'll go ahead and subtract 9 and subtract 2x from both sides. Okay, so subtracting 2x, subtracting 9. And we get negative 17 is equal to 4x. We'll divide both sides by 4, and we get negative 17 over 4 is equal to x. Okay? And that's it for that one. So you probably have one like that on the homework. Again, I usually try to pick problems that are pretty similar to what you got going on in the homework so that you have some video examples in addition to what you may already have in terms of resources. Okay, I think we got like 4 more to go. All right, number 10. X minus 1 over x plus 3 over 4 is equal to 1 over x. So I have 2 distinct denominators. I have 3 denominators, but 2 of them are the same. So you got a denominator of x twice and a denominator of 4. So the LCD there is going to be 4x. I also have a restriction, which we'll mention in a minute. So we're going to multiply everything by 4x over 1 here. That's our denominator. That's our common denominator. Our restriction is 4x cannot be 0. So if 4x cannot be 0, divide both sides by 4. So x cannot. Oh, I'm sorry. I guess technically we could say it that way, but I don't really need to. So all I really need to say is x cannot be 0, because you see you got a denominator of x there and a denominator of x there. So I think that's a little bit easier than what I was going to say. Okay, so x cannot be 0. So that's our restriction. If we get an answer of a 0, then we say that that's not a good answer. All right, so x can't be 0. Off of the first one, the x's absorb, and we'll have x minus 1 times 4. Then the 4's cancel, and then we have 3 times x. And then the x's cancel, and we have 4. Distribute the 4. Collect like terms. Add 4 to both sides. And divide by 8. So add 4 to both sides. I'm sorry, not divide by 8. Divide by 7, excuse me. Divide both sides by 7. And we get x is equal to 8 over 7. Okay? Which is not equal to our restriction there of x cannot be 0. Okay. All right. What do we got left? We have a little bit of a shortcut for dealing with equations with fractions. We can do something called cross multiplication, provided that you have one fraction on each side. If you don't, then you cannot use cross multiplication. So if I have a over b equals c over d, then we can cross multiply and say AD is equal to BC. And I can give you a little bit of an argument for that. So A over B is equal to C over D. The common denominator here is BD, so we would multiply both sides by BD over 1. The B's would absorb, and you'd have AD is equal to, and then the D's would absorb CB. And so that would be our justification for using this shortcut here. Okay, now number 11, I usually have a problem like this on the first test. You do have, I think, 1 or 2 of them in the homework, at least 2, excuse me. And we're going to use cross multiplication on it. So what we got going on is 4x plus 2 over 5x plus 9, and that's going to be equal to 4x plus 8 over 5x plus 7. Now, if I wanted to, check what the restrictions are, the way these are rigged, these particular ones, they're going to be rigged so that I don't have, I'm not going to have an extraneous or solution. I'm not going to have a bad answer. So if we subtract 9 and then divide by 5, and then if we subtract 7 and then divide by 5, that's going to be my two restrictions. Okay, so that's going to be my two restrictions. So if I get one of those answers at the very end, then I would throw out that answer. So we'll get into that a little bit later on. Okay, so those are my restrictions. All right, so let's go ahead and do our cross multiplication because we got a fraction equals a fraction. So we get 4x plus 2 times 5x plus 7. And then that's going to be equal to 5x plus 9 times 4x plus 9, 4x plus 8. And the order doesn't matter how we put those factors. So I wrote 4x plus 8, 5x plus 9. We'll have to FOIL 20x squared plus 28x plus 10x plus 14 equals 20x squared plus 36x plus 40x and then plus 72. Now you have a 20x squared on both sides, so we can cancel that out, and those will cancel out, will not be quadratic anymore. Combine your like terms, 28x plus 10x is 38x plus 14 equals 76x plus 72. We'll decide which side we want the x's on, the left-hand side, the right-hand side, doesn't matter. I think I'm going to move the 38x over, so I'm going to subtract 38x, and then I'm going to subtract 72 over, so that we get the x's on the right and the numbers on the left. So minus 38x, and then minus 72. So that gives the 38x's cancel, 72's cancel. We'll go ahead and move over here. Minus 58x is equal to, minus 58 is equal to 38x. Divide both sides by 38, and we'll go ahead and reduce. That'll be minus 29 over 19, and that's what's equal to x. That is not the same as these two here, so this is a good answer. Okay, good answer. And that is it for that problem. I got two more problems. We're going to look at solving literal equation. So the difference between these equations and the literal equation is the literal equation, I'm not going to get some sort of number as my answer. I'm going to be solving for a variable. So usually it's some sort of geometric formula, most commonly. Maybe some other types of formula, maybe some formulas with finance or whatever, and we're trying to solve for a certain variable. Let's look at two examples of literal equations here. Alright, so I'm going to solve volume equals 1/3 base times height, and we're going to solve that for the letter h. We'll solve it very similar to how we did the other ones. We're going to find what the LCD is. There's only one denominator, it's 3. So we're going to multiply both sides by 3, or 3 over 1 depending if you're a fraction or not. So we have 3 volumes. The 3's on the right hand side are going to absorb, and that's equal to BH. The B and the H are connected by multiplication, so to isolate the H, we're going to divide by B. So 3 volumes divided by B, that's equal to H. Okay, and that's it. So we don't get a numerical answer. That's our answer here. Okay. The next one is related to a geometric series formula for convergent geometric series. So if you're moving on to pre-cal, you'll see those, and then calculus 2, you'd see them again. Anyways, we're just going to solve for the common ratio here. So we have B is equal to A over 1 minus R, and we're going to solve for the letter R. Okay, so we do have a fraction, so we'll follow the process. Only one denominator, it's 1 minus R. That's our LCD. That's what we're going to multiply both sides of the equation by. So 1 minus R times B, and 1 minus R times A over 1 minus R. Since I'm multiplying, I'll go ahead and decorate everything with parentheses. Okay, we'll distribute the 1 minus r to the b on the right-hand side. So we get b and then b minus r. I'm sorry, we get b and br, sorry. B minus br. 1 minus r is absorbed. We'll subtract b from both sides, and we get negative br is equal to a minus b. Divide both sides by negative b. And so r is equal to a minus b over negative b. That is equivalent to, if we multiply the top and the bottom by negative 1, b minus a over b. You can give me whatever one of those answers, that's fine. It'll the homework system will also take that one as well. I think I have another video on this, so you can search my YouTube channel on specifically literal equations. I probably have some more stuff on linear equations. So, check your Blackboard, or take a look at my YouTube channel for more examples. You've certainly got them in your textbook too. Okay.